Hello students, welcome to lecture 11 of equilibrium. In the last class we learned about the ionic product of water, pH scale, relation between pH and H plus ion concentration which is inversely proportional, relation between pH and pOH, pH plus pOH is equal to 14, dissociation constant of weak acid Ka, its relation with alpha, degree of association, and C, molar concentration. Kb, dissociation constant of weak base and its relation with alpha, degree of ionization, and C, molar concentration. And pKa plus pKw is equal to 40. We have made list of various relations. I hope that you understood these relations. Now it is time to use those relations. We will take enough practice of the question. We should solve these questions very patiently, because if you look into the previous MCQs, examinations like NEET and KCET and JEE Main, you will see same kinds of question appears in the exam. So you should be very careful regarding solving these questions. I have already told you that you may feel that we are solving more questions, but believe me, this is the only way to prepare this type of concepts, by solving more and more questions. The first question: calculate the degree of ionization. Calculate the degree of ionization. Degree of ionization of 0.01 molar solution of HCl, hydrocyanic acid, which is a weak acid. Ka is given for HCl 4.8 into 10 raised to minus 10. Calculate hydronium ion concentration. Calculate hydronium ion, which is nothing but H plus ion, hydrated H plus ion, hydronium ion concentration. So we have to calculate alpha as well as we have to calculate the hydronium ion concentration. So alpha is nothing but square root of Ka by C. This is the relation we use. Degree of ionization is nothing but alpha, square root of Ka by C, square root of Ka, dissociation constant of weak acid is 4.8 into 10 raised to minus 10, and C is the molar concentration, which is 0.01. So it is nothing but 4.8 into 10 raised to minus 10, and this is nothing but 10 raised to minus 2. So we can write this as alpha equals to 4.8 into 10 raised to minus 10 into 10 raised to plus 2. So this becomes equals to square root of 4.8 into 10 raised to minus 8. Now square root of 10 raised to minus 8 is 10 raised to minus 4. Square root of 4.8. What is the square root of 10 raised to 4.8? It is 2.2. So this is the alpha value. No unit for this. Alpha is equal to 2.2 into 10 raised to minus 4. And they asked the hydrogen ion concentration, hydronium ion concentration. Is nothing but alpha into C. Alpha is 2 into 10 raised to minus 4. C is 0.01. They have given that. So 2 into 10 raised to minus 4 into 10 raised to minus 2. So this is 10 raised to minus 6 mole per liter, because it has no unit and it has unit mole per liter. So the same unit is for hydronium ion concentration. What is hydronium ion? It is hydrated H plus ion. means H plus ion plus H2O is nothing but hydronium ion, H3O plus ion, which is nothing but H plus ion. They may ask calculate hydrogen ion concentration, same formula alpha into C, or they may ask hydronium ion concentration, the same formula alpha into C we can use and we can calculate the term which is they ask us to calculate. Now see the next one, very simple type of, if you know the formula, just substitute and rearrange and get the answer. That is the way in which these questions are to be solved. Now question number 2, you can try yourself also. Question number 2, the dissociation constant of acetic acid. Dissociation constant is K of acetic acid, weak acid. Acetic acid is 1.8 into 10 raised to minus 5. Calculate hydronium ion concentration. Calculate hydronium ion concentration in its 0.05 molar solution. In its 0.05 molar solution. So to calculate hydronium ion concentration, we need alpha. Alpha can be calculated by square root of K into C. Or if K is given, we can use this direct formula. Hydronium ion concentration is equal to square root of K into C. Yes, we have written this formula. H plus ion concentration we have written. I have told you. It is nothing but hydronium ion concentration. So square root of Ka 1.8 into 10 raised to minus 5 and C is 0.05. So 1.8 into 10 raised to minus 5 into 10 raised to minus 2. So 1.8 into 5 is nothing but 9. 9 into 10 raised to minus 7 can be written as 90 into 10 raised to minus 8. So that square root of 10 raised to minus 8 is 10 raised to minus 4. And square root of 90 is 9.48. Square root of 90 is, yes, 9.48. And as it is hydronium ion concentration, we can write here mole per liter. Right, so again very simple question, not difficult. Only thing is that we need to identify the term which is to be calculated, term which is given, and it will be simple. See third one now. Two acids HA and HAS have values of dissociation constant as 1 into 10 raised to minus 5 and 3.6 into 10 raised to minus 10 respectively. Which acid is stronger? Simple. Which has greater K is stronger. Which acid is stronger. If we consider 0.1 molar solution of each acid, what are their hydronium ion concentration? What are their hydronium ion concentration? Now I have to say Ka of Ha, which is 1 into 10 raised to minus 5, is greater than Ka for Hx, which is 3.6 into 10 raised to minus 10. That's why we can say Ha is stronger acid. This should be our answer of first part. But now they said you calculate hydronium ion concentration of each acid. So hydronium ion concentration is nothing but square root of K into C. And we can write for Ha, hydronium ion concentration is equal to square root of K is 1 into 10 raised to minus 5 and C is 0.1. 1 into 10 raised to minus 5 into 10 raised to minus 1 for this 0.1. 10 raised to minus 6. Square root of 10 raised to minus 6 is 10 raised to minus 3 mole per liter. For Hx, hydronium ion concentration is equal to square root of K into C. K is 3.6 into 10 raised to minus 10. C is 10 raised to minus 1. 3.6 into 10 raised to minus 11. 36 into 10 raised to minus 12. Minus 6. Square root of 36 is 6. 10 raised to minus 12. Square root is 10 raised to minus 6. So these are molar concentration. We can see that minus 3 is greater than minus C. Minus 6. So Ha will release more H plus ion than the Hx. That's why it is stronger acid. Already we concluded that by comparing the value of K. So this is how these questions can be solved. See the next one. We'll take different type of question every time so that there should not be any repetition. I hope you are understanding this. You will understand better if you solve this 2-3 times. I already told you. Numericals are also need to be practiced. Then only your speed, your accuracy will increase. The most important thing is if you solve more times, you can recall them easily. In examination, you should be able to recall, otherwise there is no use of speed and accuracy. Calculate the hydronium ion concentration. Calculate the concentration of hydronium ion and OH minus ions in part A 0.01 molar HCl solution. Yes, now we can write that HCl plus H2O, it gives hydronium ion plus Cl-. This is also 1 mole and this also 1 mole by looking into equation. So you can say molar concentration of HCl is nothing but molar concentration of hydronium ion, that is equal to 0.01 molar, which is nothing but 10⁻². Mole per liter. Yes, this is our answer. They asked that only. Isn't it? They asked hydronium ion concentration, which is 10⁻12. So they asked hydronium, not only hydronium ion concentration, they asked OH minus ion concentrations. Both concentration they asked. So you can write hydronium ion concentration into OH minus ion concentration is equal to Kw, which is nothing but 10⁻14. That's why OH minus ion concentration is equal to ionic product of water divided by hydronium ion concentration, 10⁻14 divided by 10⁻². This is 10⁻². This is the OH negative ion concentration. 0.01 molar NaOH solution. 0.1 molar NaOH solution. They ask this second part of the question. NaOH we have to dissociate, and we can write Na plus and OH minus. Concentration of NaOH is concentration of OH minus, which is 0.01 molar, which is 10⁻² molar. So OH minus ion concentration we have calculated. Now hydronium ion concentration we have to calculate. Hydronium ion concentration and OH minus ion concentration, which is nothing but ionic product of water. Hydronium ion concentration is nothing but ionic product of water divided by hydroxyl ion concentration. 10⁻14 divided by 10⁻², which is nothing but 10⁻12 mole per liter. Yes. So this is not OH minus ion concentration, hydronium ion concentration, isn't it? We have calculated this as hydronium ion concentration, which is 10⁻12. Now see the next one. Calculate hydronium ion concentration in 0.05 molar, 0.005, only 1 zero is written, so it has 1 zero. 0.05 molar barium hydroxide solution. at 298K. Assuming complete ionization. Yes, they have given barium hydroxide, which is base here, which forms basic solution. So barium hydroxide solution completely dissociates and it forms Ba plus 2 ion and 2 moles of OH minus ion. Now we can say OH minus ion concentration is equal to 2 times of barium hydroxide concentration. Why? It is 1 mole, this is 2 mole. So OH minus ion concentration is equal to 2 times of barium hydroxide ion concentration. 2 times of 0.05. So this is 0.1 mole per liter. This is OH minus ion concentration. Now they ask hydronium ion concentration. Hydronium ion concentration and hydroxyl ion concentration is equal to ionic product of water, which is 10 raised to minus 14. Hydronium ion concentration is equal to 10 raised to minus 14 divided by hydroxyl ion concentration. Minus 14. 10 raised to minus 1. Minus 13 mole per liter is our answer. So this is 0.01. This is 510 and right. So this is our answer here. Now the next question is regarding the calculation of pH of solution. Calculate the pH value of calculate the pH value of 0.003 molar HCl. We can write HCl gives H plus aqueous and Cl minus aqueous. Molar concentration of HCl, H plus is nothing but molar concentration of HCl. This is also 1 mole and this also 1 mole, which is 0.003. 3 into 10 raised to minus 3 mole per liter. pH is minus log of H plus ion concentration. Minus of log of 3 into minus 3. So yes, whenever we solve this type of terms, we have to separate this minus of log of 3 plus minus of log of 10 raised to minus 3 minus of log of 3 plus this minus and log 10 raised to minus 3 is minus 10. Remember, log 10 raised to plus 2 is 2. Log 10 raised to minus 2 is minus 2 like that. So what we have here now, pH is equal to this minus minus plus 3 into log 3. Log 3 is one digit number. So I write 0 here. If it is 30, log 3 is one digit number, so 1 minus 1, 0 will write and will make point. 30 is two digit number, so 2 minus 1 is 1, we will make point. And then we will see in the log table 30 0 0. So 30 0 0 log is 0.477. This will 1.477. That is only difference. So that pH happens to be 3 minus 0.477, which is 2.52. We can round it off to 2 digit after decimal point, 2.52. Once we come to this step, we can write directly 3 minus 1 like this. These two steps you can omit here because directly minus of log of 3 into 10 raised to minus 3 is 3. Because this minus 10 raised to minus 3, 10 raised to minus 3 is minus 3, this minus is 3. Minus of log of 3. In that way we can simplify the calculation. And for log 3, we need log table. If it is in MCQs, they will give log values in question itself in bracket. Otherwise, in theory examination, you should know how to look into the log table. So this is how this question can be solved. Try yourself if you find out difficulty looking into log table. You can call me or you can come to college, I will explain. 0.005 molar NaOH solution. Now NaOH is a basic solution. NaOH, when dissociates, it forms OH minus ion. So we can write molar concentration of NaOH is equal to molar concentration of OH minus. And that equals to 0.005. So 5 into 10 raised to minus 3 molar solution. So as it is basic solution, but for calculation of pH, H plus ion concentration is needed. So we can write H plus ion concentration and OH minus ion concentration is equal to 10 raised to minus 14 ion product of water. From that, we will calculate H plus ion concentration minus 14, and this is OH minus ion concentration minus 14, and OH minus ion concentration is 5 into 10 raised to minus 3. So it is 1 by 5 plus 3 becomes 11. 0.2 into 10 raised to minus 11 means 2 into 10 raised to minus 12 mole per liter. This is the H plus ion concentration. Once we know H plus ion concentration, we can calculate pH easily. How we can calculate? pH is equal to minus of log of H plus ion concentration minus of log of 2 into 10 raised to minus 12. 12 minus 2. From where we got this 12? Log of 10 raised to minus 12 is minus 12. Minus 12 and this minus is 12. And this minus of log 2. P010 is the log 2. So this pH becomes equals to 11.7 is the pH for this. So this is the calculation of the pH if concentration is given. We'll go ahead. How many grams of NaOH must be dissolved in 1 liter of solution to have pH is equal to 12, to have solution with pH equal to 12. Aqueous solution of NaOH is basic. Why? Because NaOH is base. It will release OH minus ion. pH is equal to 12. pOH equals to 2. This we can write as pH plus pOH is equal to 14. OH minus ion concentration is equal to 10 raised to minus pOH, 10 raised to minus 2 mole per liter is the OH minus ion concentration. Now how many grams of NaOH they are asked and molarity is given. We can use this formula. Molarity is equal to mass of solute, molar mass of solute 1000 divided by volume of solution in milliliter. How many grams of NaOH is this? W2 I have to calculate. Molarity into molar mass of NaOH, volume of solution in milliliter divided by 1000. Molarity is 10 raised to minus 2. Molar mass of NaOH is 14. This is 1000. 1 liter means 1000 milliliter. And this is 1000. So you can say 0.4 gram is to be added into 1 liter so that pH will be equal to 12. Right, so this is one type of question. Now we'll see next one. Kw ionic product of water is equal to 1 into 10 raised to minus 13. Instead of 14 it is minus 13 at certain temperature. its pH and pOH. So we know that if Kw is 10 raised to minus 14, H plus ion concentration is 10 raised to minus 7, pH is equal to 7. OH minus ion concentration is 10 raised to minus 7, pOH is equal to 7. This we know already. So half of that, and pH is nothing but negative log of 10 raised to minus 7, and it becomes 7, right? Now they said K equals to 1 into 10 raised to minus 30, so you can say pH is equal to 13 by 2, which is 6.5, and pOH is also equal to 13 by 2, which is equal to 6.5. So this is how we can make half of it, and we get the pH and pOH. Next type of question. Calculate pH of following solution. Calculate pH of following solutions. 2 gram Thallium hydroxide, dissolved in water to give 2-liter solution. Molar mass of PLOH is 221 gram per mole. Now first we will calculate OH minus ion concentration. For that, molarity is needed. Into 1000 by V. This is 2 and this is 221. This is 1000. And 2 liter means 2000. So this molarity is equal to 4.52 into 10 raised to minus 3 mole per liter. So molar concentration of OH negative ion is equal to molar concentration of thallium hydroxide ion, 4.2 into 10 raised to minus 3 mole per liter, and H plus ion concentration is equal to 10 raised to minus 14 by OH minus ion concentration. So H plus ion concentration is 2.21 into 10 raised to minus 12. Is the H plus ion concentration. Once we know H plus ion concentration, we can calculate the pH. How? pH is nothing but negative log of H plus ion concentration. pH is nothing but negative log of H plus ion concentration. Negative log of 2.21 into 10 raised to minus 12. 12 minus log of 2.21. Log of 2.21 is 0.3424. And that's why pH is equal to 11.66. Right, so I will give 3 questions as a homework. Let's see how you calculate that. B is 0.3 gram of calcium hydroxide dissolved in water to give 500 milliliter of solution. Gram molar mass of calcium hydroxide is equal to 74 gram per mole. Same question. Remember that one calcium hydroxide gives 2 moles of hydroxide ion. So molar concentration of hydroxide ion is equal to 2 times of calcium hydroxide concentration. Let's see how we do it. Here I am doing this as homework. 0.3 gram of NaOH dissolved in water to give 200 milliliter of solution, and D is 1 milliliter of 13.6 molar HCl is diluted with water to give 1 liter of solution. So these 3 questions I have given you for homework. So solve these numericals once again. If you are finding any difficulty, come to college and I will explain them. You should know how to see log table and how to write correct values, because all the relations are logarithmic relations. Practice is needed. Complete sincerely this homework, try to solve that. Maybe your answer is correct or wrong, it doesn't matter whether you tried or not. That is very important. Thank you for watching this video.